All right, this is the second video for one sample proportion. This is specifically on confidence intervals. So remember, a confidence interval just says it's a best guess as to where the true population parameter lies. And we have our estimate plus or minus our margin of error. So when we were working with means, we had our best estimate was the X bar was our mean, our sample mean. That was our best estimate. Plus or minus, we had T star S divided by the square root of N. And when we were working with populations, we would say, you know what, is X bar plus or minus Z star. And everything that came after the plus or minus was our margin of error. And our best estimate was the X bar or the sample mean. Well, when we work with proportions, our best estimate is P hat. And we're going to be in all proportions. And by the way, this is true for all proportions or Z stars. So we're working with the P hat, so my sample proportion. So this is my sample proportion is my best estimate. So sample proportion. And then my rest of it is going to be P hat, Q hat over N. So that's my formula, all right? You're going to need to read the rest of this yourself. Please make sure that you understand this. And one thing to pay very, very careful attention to is P hat and Q hat are from the sample. All right, P hat and Q hat are from the sample. That's not the claim. So this value and this value have to be exactly the same. All right, this is different. Please note this is different than when we did the hypothesis test. Because in a hypothesis test, we use the claim in the denominator. Here we have to use the sample. So it's easy to get those confused. So make sure you're using the sample and make sure you're using the initial claim here. Okay, so make sure you don't mess that up. All right, that's a big thing to be careful with. Everything else is going to follow fairly much the same. We'll take a look at what we have to do in our recipe for success. Once again, we're going to have to define our parameter. So let P naught equals, or let the true population proportion. So we're going to go ahead and write that. Let P equal the, or P naught equal the true population proportion. You are going to have to address conditions. The simple random sample, not so worried about. N is less than 10%, not going to worry about. But this right here, you're going to have to do this to check for normality to make sure the sample is large enough. And once again, they both must be greater than 10. All right. And remember, P hat is the sample proportion, and P hat equals X over N. Q hat is just 1 minus P hat. All right. Q hat is just 1 minus P hat. N is the sample size. Once again, here's our formula. Please note the same values. And this is the sample proportion. All right. Here's a list of where things came from. P hat equals X divided by N, etc. Make sure you know those things. And then it's going to run just like a regular confidence interval and with the same sort of conclusion. So I don't think you'll have any problem from this part on. Excuse me. From below the line on, it should be very, very straightforward, very much the same as what we've always done. So let's go ahead and look at this previous scenario that we did with a hypothesis test and do a confidence interval. The local news has taken a simple random sample of union members and found that 87 out of 125 union members surveys said they will strike, calculated 95% confidence interval, and provide a conclusion. All right, so they said they want to know, it doesn't say this, but they want to know the population proportion. And the reason I know this is this is 87 out of 125. I have counts. I do not have I do not have an X bar. There's no X bar. So since there's no X bar, which means there's no sample mean or population mean, I need to do a proportion. So let P naught equal the true population proportion of union members who will strike. All right. And let's go ahead and find out what P hat is, just because I find that that's a really good thing to do early on. So P hat equals X over N. And X, we expect 87 to strike out of 125. When I divide 87 divided by 125 is 0.696. So P hat equals 0.696. And it's just because we can do it really quickly, let's do Q hat is 1 minus the 0.696. And I end up getting 0.304. All right, so we've done that part of it. What's the next thing it says do? Oh, we need to check our conditions. And the only one that we're going to worry about is whether we have, this is for normality. And by the way, you probably need to know this word. This is the one we check for normality. Is our sample large enough? And it's large enough if these two multiplied together give me are greater than 10, and these two are greater than 10. Well, I'm going to go ahead and write those down. N P hat has to be greater than or equal to 10. And N Q hat has to be greater than or equal to 10. Well, in P hat, N is 125. 125 times 0.696 is 87. That's greater than or equal to 10. That's good enough. Over here, 125, and we need Q hat. Well, we calculated it and said it was 0.304. That's 38. And that's greater than or equal to 10. And by the way, all you need to do is write that. If you just say that's greater than or equal to 10, that's fine. All right. What you're really saying is it's large enough to use the normal approximation of the binomial. But right now, this will work for us. Okay. So we're going to write our equation. P hat plus or minus Z star P hat Q hat over N. So we're going to go ahead and plug in what we know. Well, what do I know? I know P hat, 0.696 plus or minus. I don't know Z star yet, but we'll get to that in a moment. I also know P hat here, which is also 0.696. I know Q hat is 0.304. And I know my sample size is 125. So now I need to go calculate my Z star. And that's just the way we've always done it. We're going to go second vars, inverse norm, parenthesis, 1 minus 0.95, close parenthesis, divided by 2. And we end up getting 1 point, and always make it positive, so that's not changing, 1.9599 or 1.96, something like that. All right, that'll work for that. We've written everything down, so now we can let the calculator do its work. So stat test, and this is going to be a little bit of a scroll, and you're going to keep to sample Z interval and keep going, Keep going. And it's to letter A, which is a 1 proportion Z interval. 87 is our number of successes. 125. So basically, this is the information for p hat. And I need a confidence level, they said, of 0.95. So here's my interval. My interval is 0.61536. That's my lower bound. My upper bound is 0.77664. All right. So there's my interval. So let's go ahead and write our conclusion. We are 95% confident that the true population, be careful, we're talking about proportions, proportion, oops, should be careful and spell it, proportion of union members who will strike lies within the interval 0.61536 to 0.77664. All right. So that takes care of that. Now, what's interesting about that is on the hypothesis test, not on this one, but on a hypothesis test, there was a claim, the union claimed that 75%, this was not on the confidence interval, but on a hypothesis test, they claimed that 75%. Well, 75% lies within that interval, okay? 75% lies within the interval. And even though they didn't ask us this, we can say the union members' claim of 75% is plausible. All right? It's plausible because it lies within the interval. All right? Because the interval went from 61 to 75, 77, 75% in there, so it's plausible. Okay, doesn't mean it's right, but it's plausible based on our confidence interval. They did not ask this question, but I wanted to relate that back to the hypothesis test. All right, thank you for watching the video.